This is the first live session from the Getting Started with the Simulation on 3D Experience platform series. So in coming sessions throughout the year, we are exploring a range of a topic like simulation model building, structural simulations, durability simulations, then plastic injection molding, then electromagnetic simulation, motion analysis, and a lot more. And trying to providing you insights to help your knowledge on 3D Experience platform and technical skills. So these our sessions are designed to be interactive, and you're allowed to ask questions. So if you have any questions or comment, please drop them into chat box. We are continuously monitoring these chat boxes. So and then we'll try to answer you all questions as it pops up. We hope you enjoy the series and come away with the new ideas and inspiration. So sit back, relax, and let's get started. And then, well, before that, if you haven't subscribed the channel yet, please do subscribe, like, and share, and enjoy what all the greatest content anytime from anywhere. I am Sagar Mandwe from Simili IPS team, and we are here with the Greg Albrechtson. So Greg, did I say it correct?
I was going to say, no, I was waiting for that because, if I had to say your last name, I would definitely butcher it. But no, you did great. I think you say it probably better than I do. So my dad would be proud.
Glad to know that.
Yeah. I'll have to take lessons from you how to pronounce my name.
Oh, anytime. So today we are going to talk about two topics. First one is what is 3D experience work simulation, and the second one is how to collaborate efficiently for accelerating innovation. So I will be taking you through the collaboration on the 3D experience platform, and Greg will be speaking about 3D experience work simulation. He is a structural simulation expert and has always focused on delivering workflows or the techniques to bridge the gap between designers and simulation experts. Did I say it right?
Yeah. So that's kind of, I've done a lot of high-end simulation. I've done a lot of design, but my passion is really bringing those two communities together, because historically the designers have done their thing, the simulation experts have done their thing, and they're exporting step files, and somebody makes a design rev, and then it takes a week before you get your new simulation results. But so bringing those two communities closer together, and then really, streamlining and expediting that workflow is, what we're able to do on the platform. And today's going to be a definite introduction in, how that works, and in particular for the SolidWorks user as well. So that's what we're hoping to cover today.
Yes. So the topic is 3D experience work simulation, and Greg, the floor is yours.
Thanks. Hey everybody. Again, thanks for joining our first YouTube live session. And as Sagar mentioned, we're going to have several of these, and the schedule as it sits right now is this same time. About every third week of each month is when a new session will be released, and then we'll go over a new topic. The topic today is really just a high-level overview. You're getting a double whammy today. I'm going to give you a high-level overview of how to perform a simulation on the platform with SolidWorks geometry, and then Sagar is going to follow up with that and show you some of the great tools that we have in what we call a dashboard, but it's basically a web browser, how you can go through and start to interrogate some of those models in your data, your simulation data, directly in like a little web browser environment. So this is I'm not going to bore you with PowerPoints because, death by PowerPoint, right? I mean, we can just sit and look at PowerPoints all day long. I've only got a couple slides I want to show you, and then I'm really going to dive into the software and show you, how we start doing some of these simulations in the platform. But this gives us a pretty good high-level overview of what we're going to go through with this particular series. we have an e-bike that we have designed and developed, or in the process of designing and developing, and other aspects related to riding a bicycle. And we're going to go through a series of different things. So we'll talk about electromotor performance, thermal flow. How do we do thermal flow, like CFD? How do we do strength and durability, impact simulations, injection molding, motion analysis, electromagnetics, because this is an e-bike. Maybe we have a Bluetooth cyclometer device up here. Maybe we need to look at electromagnetics of the battery, maybe overheating. So we're going to bring all these together in a full-on story of how this e-bike, how someone would go through developing an e-bike. And that's kind of it. One last slide. And again, this really kind of comes together at what my goal is. For many years, I have been focused in design or CAD integrated sort of analysis solutions. One of the difficulties that we have as industry experts is there's not really enough simulation experts out there to accomplish all of the problems that we have before us, or all of the type of simulations we want to perform. If we gathered all of the high-end skilled traditional analysts in the world, we could probably fit the majority of all of them in one soccer stadium. I mean, soccer stadiums are big now, right? I mean, we saw the World Cup this past year, and they're getting big. But really, if you think about it, that's not that many people. And across industry, inside of these different industry realms, if you think about one, typical organization, they may have one analyst specialist to 5 or maybe even 10 designers. And so my goal, again, is to bring those communities together, enable more people to be able to do more simulations, no matter what your skill level is. You can do this as a design verification, validation tool. Maybe just make some simple changes to the model, see how it performs. Is it going to deflect more? Do I change where my stresses are? Of course, we want to know if our parts are going to break, but sometimes we can just use it as a simple design tool to find out where our high stresses are, or how it's going to displace. Something as simple as putting a unit load of 1 on a model. Even if I don't know what the load is, if I just put a unit load of 1 on there, again, I may not know what the real stresses are, but I have an idea how that product is going to behave under proper loading. So if I want to lightweight it or do some different things like that, that will give me some predictive sort of places where I can remove material, where I should add material. So there's a lot of advantages, from a high-end simulation, electromagnetics or whatever, to just basic rudimentary using it as a design tool. And so that's my goal, is to really bring those communities together and get more people using the software so you can design better products faster. All right, that's enough.
Yes, Greg, I do agree with you. If you get the insights of a product well before it's manufacturing, then it's way better. So I just have one thing to say to the audience, that if you have, guys, this is interactive session. If you have any questions, please go ahead and ask it in chat box. We are monitoring it. Also, if you haven't yet subscribed the channel, please go and subscribe and share the channel.
Yeah. Please ask questions. I have some stuff that I want to talk about, but I love to go off on tangents. So, any question. What color socks am I wearing? I'm actually not wearing socks. No, I'm just kidding. I'm wearing socks, just not shoes. Anyway, we know how all this YouTube stuff goes. But yeah, for sure. Yeah. Just send questions if you guys have questions. My pleasure. So part of riding a bicycle is wearing a helmet. And I thought this would be a really nice place to start, rather than going into a complex assembly with weldments and different things like that. I want to give you a brief overview of, just taking a product from design through a quick simulation and doing some different things like that. I'm by no means a good SolidWorks user. I know enough to get in here and basically take some stuff from SolidWorks to 3D Experience, because that's where my skill set is at. But So we have this part. We can see over here. It's an assembly comprising of some different components. And one thing that you'll notice is I have over here on the right hand side is this is a simple add-in that enables us to start to interact with 3D experience. So you're able to work in your normal sort of SolidWorks environment. Immediately when I hit save, even if I go, and I hit save up here, what happens is that then starts to, if you're connected to the 3D Experience Cloud tenant, that will then take this information and it will save it in that particular cloud tenant. And the great thing about that is now everything is connected. So in the end, when I start to create some results and I have, some simulation displacements and stresses, I'm so bad at organization. I have a folder system.
Me too. Yeah.
Especially, you think engineers are type A people, but
Yes.
I'm maybe like a type A minus. Who knows? File naming, right? So if I have a result and I'm like, okay, find mesh number 1, and I save it, and then I do another one. I find mesh number 2, and then I'm like final mesh, like final.
Yeah.
You just, all that stuff gets disconnected, and you have no idea which result was with which original file. The platform takes care of it. I don't even have to think about it, and I love that. So maybe that.
Yeah, I think that's the best thing what platform is offering to organize your data very effectively.
Yeah. So maybe if you don't get anything else out of this, just know that it's going to organize your data, and it's going to help your life that way. It's not going to help the rest of your life, but it'll help this aspect of your life. Anyway, so I have a model here. I've saved it. The other thing that I'll want to do, I have some other different options here. I can do some different saving options. I can reserve this. I can save this. I can do some other types of things to save this model and propagate it to the database.
So Greg, if that green tick is there, that means it is saved on cloud, right?
Yeah. That green tick means it's saved on cloud. Because, prior to this, I had to do some setup. I had like a little yellow click me, save me to the cloud. And so it would tell me here that it was only saved local on my desktop and it was not saved to the cloud. Yeah, exactly right. Yeah. See, organization. It even tells me if I've saved it or not, right?
Yes.
So, yeah. So I can highlight any one of these parts, and if I want to go right to creating a simulation, I have this nice little tab down here, and I can pick simulation, and it will go ahead. It will launch 3D Experience. It will start to create the structure that it needs for a simulation. But I'm a little old school. I like to do things a little bit more manual. So when I clicked on the compass here, what that did is that launch, and that shows me all of the roles or licenses of things that I have access to. And so obviously I work for the company, so I have a lot of access. Maybe they should take some of my access away.
But no, you are the prime expert from us.
Yeah. So I'm gonna select something called collaborative lifecycle. This is my favorite one to launch in. It basically just kind of launches 3D Experience into a data management sort of environment. So we can see 3D Experience is launching here, and it launched it in a screen behind. So now I can just kind of Alt-Tab to the screen here, and we can see here is that helmet that loaded it inside of my 3D Experience kind of session. So the only thing I need to do here now is just go ahead and right-click, open it. And there we go. And now I have the helmet. So we can see it has the same basic kind of structure. I have a compass. All this.
Nothing is left behind. He has carried everything. Yeah.
Right. Yeah. Everything's left behind. I'm not going to get into this today, but if I had created a SolidWorks simulation and I had done the same thing, that would have brought the SolidWorks simulation in here and basically, put it in 3D experience format. So it would have brought the mesh over, the materials, the loads, the boundary conditions, as long as those sort of items are supported here, it would have brought those over, and the majority of those are supported. So again, if you just want to add that higher level of fidelity or a more expanded level of simulation, we can go ahead and do that directly here as well. One of the other things that's really nice is this is the structure. So if I start expanding this, I see this little do not enter sign. What that means is the right privileges to modify the geometry have retained in SolidWorks.
Oh.
So I can defeature, I can do all sorts of geometry prep here, but to the actual authoring and ownership of the model to modify the features and parameters and those kinds of things, that still exists and is managed by SolidWorks. And so that's kind of a nice thing to think about. So I can create my simulation geometry if I want to defeature some fillets, remove some holes, maybe add some features. I can do that all at the time of not modifying my original geometry that was in SolidWorks. So it's kind of
yes. Yeah, it's a great feature. I think you keep your geometry intact, and in the platform you just take control over the parts that will be involved. Those will be involved in the simulation only.
Yeah. And I think in a later session when we start talking about optimization and designs of experiments, we'll talk about how features move back and forth, or how parameters can move between the two systems.
Yes.
So let's create a simulation, right? That's why we're here. So I'm going to go up to the compass. Again, I'm going to go to, we have a lot of different tools, but I'm going to go to something called mechanical scenario creation. And this is going to create the structure that I need for a simulation. So you'll notice it didn't look like much happened, but I have a new tab up here. So now I have a simulation tab. My helmet is now stuffed under this physics simulation, and it's asking me some questions over here. So the first thing it wants to know is, what type of simulation am I going to run? I'm just going to take a lot of defaults today. I'm just going to keep it with general. So I'm just going to do a basic static simulation. If I had already used this model in a different simulation and I had meshed it in a previous simulation, that would show up here. And so that's one of the great advantages is I can reuse meshes from other simulations. So, if I'm running various types of load cases or different things like that, I don't have to sit and mesh it every time, right, man? I can just reuse. And that's one of the things that extends through this whole scenario. But I don't have a mesh, so let's make one. So I'm going to create something that we call a finite element model, finite element mesh. I have a number of ways to do this. If I just hit automatic, that's going to look at this tree here, and it's going to create a element placeholder for each entity in here. I don't really care about the straps and stuff like that. That's not really going to pertain to the model. So, classically, you'd be like, oh, shoot, I need to go back to SolidWorks. I need to remove those, but I don't need to, because what I can do in this model is I can basically just tell it which items I want to include in my particular simulation. So I am just selecting those items that I want to have it create a mesh entity for. So I just selected the foam and the shell.
Okay.
And all these parts will stay in the history of the assembly, but when it creates the actual simulation, it's going to hide them. It's going to remove them. So that's pretty nice. So I can still keep the integrity of this model. Maybe if if this is the bike, maybe if I want to just run a quick simulation on the frame, and maybe later down the road I wanted to add those other components in, I can do that. I can come here and I can add or remove items in here as I wish. Okay. So let's go ahead and I'm just going to hit update. You can see it assigned a default mesh size here. I can go in, I can modify that. I can change that. Obviously, I can make it whatever size I want. I'm just going to go ahead and do the default. I'm going to close that. And we can see that my foam is pretty thick and my shell's pretty thin. You know, if I'm meshing something that's like this kind of thin, it's probably not a good idea to use TETs. For the foam, TETs are perfect. They're fine. But for the shell, TETs aren't going to be a good thing to do on that. So what I'm going to do is now I'm going to override what the default mesh told me to specify. And I am going to create a manual mesh, something that's a little bit better for that foam. So let me go, or for the shell, let me hide the foam. Let me hide this thing. I can do all sorts of stuff, right? So I can work in a different little context. So what I'm going to do, I'm going to create a hex mesh. And I'm going to pick this for my item. I want a hex mesh. And I'm going to basically create a sweep hex mesh. We have a nice tool here that allows me to pick the inside surface. Some dialog boxes out of the way here. I'm going to say propagate. And so what that's going to do is that's going to pick all of the inside surfaces. And I'm going to say I want to sweep to the outside. Move this back over here. Sorry about that.
So you are creating mesh for cell from the bottom surface to the outermost surface, inner surface from the outermost surface.
Yeah. So basically what's going to happen is the software is going to create a quad mesh on this inside blue purple surface. And it's going to sweep that, or it's going to extrude that, through to this other purple surface here. And so what that allows us to do now is that allows us to create a much better mesh that has better refinement for this type of simulation. And we have some really nice advanced tools in here. You still might be going, hey man, that's still only one element through the thickness. Well, we have some advanced analysis capabilities in here where I can mesh this as a solid hex, but I can use shell theory. So in essence, this is I can use this as a shell theory through that. And so that gives me really great accuracy of having just this basic simple mesh. And I can still model this all as a solid. I don't have to do any mid-surface extraction and figure out what to do with that gap between them and all of that. So it's a really, really nice, neat sort of process. Okay, so there we go. So we've got that meshed. It's very contextual. I'm going to double click on the physics simulation up here. We can see my workbench changes down here. I'm going to go to setup. I'm going to say a procedure. I'm just going to take the default. I'm just going to do a static simulation. Whoops, I need to turn my foam back on. I'm going to hide the mesh because I don't want to look at the mesh anymore. So we'll just have a look here. All right, let's add some boundary conditions. I'll just go ahead. I'll clamp maybe here. Spin this around. Clamping. Doing pretty good. And let's go ahead and put a load. Select loads. Lots of different types of loads. I'll say remote force. Let's just go ahead and pick those for the force location. Maybe we'll do simulate an impact to a tree or something like that. Watch what I do here. So this says newtons, but I live in the US. We have no idea what a newton is. So I'm going to say pound force, and it just converts it for me. So
that's awesome.
Yeah, dude, it's so awesome. It's so great. And then, the other thing is, I get a little compass out here, and I can get really detailed, or I can just kind of click and drag the orientation of that, whatever I want to do. And there it is. Oh, you might think, well, what about the interaction between those two? That's just going to go straight through. Yeah, right. So we have something here that's called general contact, and what that does is during solution time, I don't have to pick all of my contact pairs. I don't have to say this surface and this surface touch and this one touch. What it says is, all right, when you're solving, just look at all of your surfaces, all your element locations, and software, you figure out if stuff is going to touch or not. And so it's a really, really nice way to do complex sort of contact like this, where I have all these crazy little surfaces back here, and you know, I don't have to deal with it. And that's it. And then I basically just send this off to the solver. Well, as the magic of cooking shows have, is now I reach over to the oven and I pull out my fully cooked bread. We can have a look at my fully cooked bread here, so we don't have to sit and watch it bake. But this simulation probably only takes a couple minutes. It's not that long. But here we go. Now we have our solution here, and I mean it's really that straightforward. To put a simulation together on the platform. It can be as simple as this. It can be as complex as we need to. So when I save this, it saves it to the database. It's still attached to the model. If I go back and change that SolidWorks geometry, all I have to do is hit the little update button. That new geometry comes in, and I rerun it, and that's it. It's that straight.
Yeah. That's awesome. The color contour on the helmet, the stresses level at the different points looks amazing.
Yeah. It's really easy to interrogate the models here. We've got all sorts of other little flip ups. If I just want to look at the stresses on the foam, then I can just look at the foam itself, turning other things on or off. Whatever, can turn it all back on, and go ahead and start to interrogate the model. And that's kind of it. I mean, it's pretty cut and dry, pretty straightforward. That's really what I wanted to cover in my portion of this session. And then obviously, as this series keeps going, we're gonna add complexity to this.
Yes. We are exploring different topics like eMAG, from plastic, from motion. Everything will be covered as we go ahead. So thanks, Greg, for this wonderful session and explaining how you can set easily the simulation in 3D Experience platform from SolidWorks.
Yeah.
So here we have a question from Mark Peterson. He's asking, can the plot be animated?
It can, yep. So the plot can be animated just like that. So I just hit this little play button up here. It starts to animate it. I can still spin it around while it's being animated. You can export this. You can save this as like a little MPG file. Lots of other types of animation things you can do. And obviously, I was showing this. Whoops, I think I just hit everything.
But basically you can plot the animation. You can capture the animation of deformation, different stress contours.
Yep. Okay. Yep. You can capture all of that, no problem.
Yeah. So guys, if you have questions, please go ahead. Please feel free to ask questions in the chat box. And if you haven't subscribed it yet, please go ahead and subscribe the channel. So now it's time for me to get into presenter's seat and Greg, you to be the guest.
Yeah. So now we're going to change roles. So now Sagar is going to present. So again, if you guys have questions, and if you think of a question later, send us an email or a contact, or even throw it. Better yet, throw it in the question when the YouTube live gets posted. We'll kind of monitor that as it goes as well.
Yes. Okay, so let's get started with my topic today, and I will be talking about 3D Experience the collaboration aspect of a 3D experience platform. So I will take you to, let me share again. Yeah, so it is there. So Greg has explained what is 3D experience work simulation. I will quickly give an overview for you guys to understand a little bit more about 3D experience work simulation. So what is 3D experience works? And to answer this, I will let's start with a question again. So if you look around and check for what companies are targeting these days, then probably you will get to know that every sector, every industry, every company is targeting high quality product quickly and cost effectively. So here is the question: how to achieve these? How to produce high quality product quickly and cost effectively? For that, companies need to have workflow streamlined associated with the product development. And here is the real question: how to streamline the workflows associated with the product development. And for that, the only answer is you need to have a product development solution that provides all the necessary tools in a single environment. That's exactly what 3D experience works portfolio offers. So with 3D experience work simulation, right from concept to final assembly work, so you can now do concurrently in a single environment, in a seamlessly integrated and managed environment. So that said, right from design, engineering, then simulation, manufacturing, and marketing and governance, all things can be takes place. You can do using 3D experience work simulation. So to conclude this, what 3D experience works helps you. So it's like it eliminates the need for multiple softwares. You get everything under one roof. From it may be from a simulation, it may be from a governance point of view, it may be from a marketing point of view. So it eliminates need of a multiple softwares. Then as you work in a silos, there will be there will be time consumption and a cost associated with the data's translation. And with the 3D experience works, you can reduce that and you can reduce the communication error. And by that means you can easily streamline your workflows, reduce development time, and produce higher quality products. So this is what I was willing to explain you as a 3D experience works portfolio. So I will go in deep with the actual dashboard things to explain you what 3D experience works exactly is.
Yeah. The one thing I noticed on that previous slide, there's one thing that's wrong on that previous slide, and it's that the rider on the bike doesn't have a helmet.
Ah, yeah,
So
yeah.
that,
Yeah, we thought, I was like, in the morning only we had a word of that. We can have a helmet
yeah,
on that rider.
yeah, we need to give her a helmet for sure. Because don't
Yes,
ever
yes,
ride without a
yes.
helmet.
Yeah, yeah, it's
Yeah.
a safety point of view. So, so now I'm sharing my second screen where the actual dashboard is there. Yeah, is it, can you see my screen now?
It came up and then it went away. There you go.
Oh, yeah.
Perfect.
So we are in a platform UI where from this Compass 3D Experience platform Compass, you can directly get to know about the 3D Experience works portfolio. So under here you have 3D experience works where design, these are the domains we have work this portfolio in different domains. So
Um,
let's say if I'm exploring
so we
simulation
lost your
domain.
audio there for a second.
Oh,
There you go. Now you're back. Now is this
okay.
is this is this in a web browser or is this the
Yes, it is a web
okay?
browser on a cloud.
Okay. Any particular web browser?
I'm using Google currently.
Okay.
So So as you see, 3D Experience Works portfolio is across these domains, and under simulation, this is a domain we are covering throughout the year. You will find these many subdomains. So it's right from structures, computational fluid dynamics, plastic injection, EMAG, motion, and simulation review. So under these domains, we are offering different roles, and then under different roles, you will see different apps. So for structures, these many roles are there. So if your simulation or structural simulation is a static or a non-linear, then also you can perform, and even durability analysis simulations can be done using these workflow.
So so a role is that like a pre-packaged kind of set of capability in the
Yes,
platform?
yeah, yes. These are the the roles comes up with the different apps. So I currently I'm in a structural designer role. You will get access to these many apps, and using
Okay.
these many apps, you will set your simulation. You can collaborate with others. You can manage the total data on cloud, related simulations on a cloud. So it is a complete package. Role is a package basically.
Okay.
So this is all about 3D Experience Works portfolio. So now let's talk about the collaboration. So currently I'm in UI of a platform, 3 dashboard. So this is a dashboard where you can see your dashboard name over here. Currently it is 3D Experience Works eBike. Then your profile, your cloud name. The bell icon is for the notifications. The plus icon is to add dashboard or tab, whatever related to your work. You can add a story, you can add widget. Then this is a share button. You can share this dashboard directly with your teammate, or whoever is having access to this demo tenant, or cloud. And these three dots are the content where you have, you can directly access your content from dashboard through this icon. And this is a swim community icon. So right now I'm in a dashboard UI. If I want to switch into community UI, then straight away go and hit this button.
So what's swimming? I can't
Swim.
swim. I don't know how to swim. I live in the mountains.
Yeah.
Remember that?
Yes,
We
yes,
don't swim here.
yes. So Swim, 3D Swim is a platforms app. It is a community app where you can. So right now you are seeing the 3D Swim widget over here. So here you can see communities and a conversation. So it's a
Okay.
communities connect people and data through live and engaging experience. So here you can add your post, add your idea, your questions, your media, whatever you find about your project, you can simply add it over here, and it will be available for a good set of people uh, who has access to this particular community.
Okay. So it's not really like it's not a news group, but it's kind of like that where if you have questions or and you can post
Yeah.
questions or just kind of share information with other
Yes.
people and so it's a place to
So right now,
collaborate. You know.
if you, yes, exactly. You can take a snapshot of your simulation. You can comment, add your comment. So if you see this one, this is a battery casing of a e-bike. The deformation of this strip is way higher, which is beyond the acceptance limit. So I particularly circled it out and made a post in this particular community.
Gotcha.
Again, you can have a conversation with your teammates and colleagues. Right now I'm with Greg, and this is a conversation where I can type whatever I want. I can have a chat with Greg. These conversations will be for limited group of people, and you can save it for life long time. You can pop up the timeline. You can you can add the timeline as you go on. So this is about the 3D swim widget. And yeah, this is very cool widget, 3D play. where you can see your geometry in real time. You can rotate it, you can see, you can zoom it. So these are the different uh, these are the different commands on action bar for view, for rotate, for zoom in. And the best part of the platform is if you go to the your profile and under preferences, you will get the oh, it's popping up. You will get the commands on language and mouse control. So if you are anywhere from the world, you can set your language for the platform. And for mouse control, if you are basically SolidWorks user, you can set it for SolidWorks. If you are CATIA users, then hit for CATIA. And for 3D experience, if you are fond of or working on a platform, then just hit this button. So I'm keeping it as a SolidWorks. So whatever mouse controls are there for SolidWorks, you can have it over here.
That's
So
cool.
no confusion.
So this isn't a web browser, right? This isn't
Yes,
this
yes,
isn't
yes.
what I was using to design with. So any anything that you can open a web browser in, you can you can view this. And is this just for like parts or um, simulation data?
So So whenever you are in a 3D play, whenever you are handling CAD data and simulation data, you can have these preferences. Even I think not only on a web browser, but if you are in a platform, then also you can set your preferences, and accordingly you can work in platform UI
Okay.
as well.
So
So
so I could share this with my design manager who I don't actually want to touch my data and mess it up. I could just share this with them so they could see my parts and my
yes, yes,
results, right? And
exactly.
they don't have to have
Yeah,
the
yeah.
heavy client installed or anything like that. Okay,
Correct, correct.
cool.
You got me.
Yeah,
Yes.
cool.
So these are the tools for view your 3D model. But if you go to the tools, you will get to know that if you have an assembly over here, and if you want to hide some parts from that and look into the inner part, then this is the icon or command you can use. But right now the handlebar grip is a single geometry, so I'm not going to demonstrate it, but it is there. Also this is a explode. So likewise, if you have assembly and you want to have an exploded view of it, then you can just click on that. The geometry or the assembly will explode. You can have details, or you can see each and every part. You can measure. So let me show you that if you want to measure distance between any particular point or the angle, you can do it over here. So I have selected these 2 points, and it is saying me that it is 32.995 mm apart from each other. And you can erase that way. This is what I love about this. You can see the section view. So I'm handling that handle gripper. I want to see what's inside that with the different sections. So simply by removing these, by moving the plane, you can see how it
Oh, that's
looks like when you have
so
a
cool.
section.
I, I could
Even
I
if
could
you
do that
want
for
to
like an
see,
hour.
yeah. So right now it is about this axis. If I change, you will see like this. From different orientation, different axes, you can have a cross section view of it. And to come out of it, just hit here.
And this is just a part. I assume like this would be a great way to look inside an assembly or something, right?
Yes, yes, yes. And let's say if I'm in a cut section and I want to have a comment over there, like, so I have to share remark to my manager or my teammate that look, these patterns are not that good. You can go to the annotation, it is there, the pencil icon. You can click on that, and let's say if this curve is not appropriate, I will circle it out and simply getting out of it, and you can add your remark over here. So new text pops up. So let's say it's a remark. It's a remark, and if I saved it, and so now what happens, I want to share this one with the community. So so from here only you can directly uh, share your post, your remark to the community that I have showed you in the collaboration tab in the platform in the community where uh, that that snap pops up with your comment.
Cool.
So how to get these geometries in a 3D place? So now let's search for one e-bike frame. I have uploaded it into on cloud in uh, e-bike specific collaborative space, and now I'm searching it right from the dashboard from the search window, and you can see over here 26 results are there, and from that you can take the simulation results or uh, simply the product or 3D geometry. So select it and drag and drop over the 3D play. The geometry will get into this widget very soon.
Yeah. I mean, this is awesome because you and I are like 12 and a half hours time zone apart, and we can
Yeah.
work on, we can, I mean, true collaborative engineering is a reality now, right? I mean, we can work on the same
Yes.
thing. So when you go to bed, I can keep working, and when I go to
Yes.
bed,
Yes.
you can
Yes.
keep working. So yeah, I mean, that's
Yep.
just
Absolutely.
that's just so awesome.
And that's where we reduce the time and we have a better and efficient collaboration. That's what we call it.
Yeah.
So this is by this way you can have a geometry or a 3D part in a 3D play. Then moving onward, we have 3D drive where you can store your data under my files. Just clicking new, you can create a folder or upload the file, or directly you can upload the folder from your system. So it's a storage location where you can share data with the people of your team. And this is a web note. I oftenly use this one just to have meeting notes or your work status kind of thing. Or if you have a specific set of links to particular post or particular videos, then you can collect and keep it here in web notes. So using these apps, these are the fewer. We have a lot, but for 3D experience work simulation, these are the main or preferred to use for collaboration. Moving forward, just talk about planning. Yeah, and planning is a key to success. People say so. If you are better at a plan, you will definitely get succeed.
Well,
Along with talent.
I need to figure out how to run this desktop then. This one here, because
Yes, yes, yes. I'm there. I'm there. I'm here to help you.
yeah,
So we have a project called eBike, and these many tasks are there. Here you can clearly see the timeline. Different dates are there. The dark blue says the percentage of activity that is completed, and the light blue is the remaining part of the task. And here you see GASE. These are the your teammates initials. So this checklist and approval for qualifying new vendor that was assigned to Greg, and it is already completed. So
you assigned me
just like
something.
this, yes, it was assigned you, and you finished
Oh,
it
good.
way earlier.
Okay, good, good.
So in project planning, this is a tab where you can see the overview of your task and how it is going. Along with that, we have the collaborative task where you can filter out what tasks are assigned to you. So basically, here is a filter icon. If I filter it by status, then these three columns will be there. If I filter it with maturity, then the draft, to do, in work, in approval and completed. So this way you will get your task assigned to you or owned by you. And if you click on any one of it, so let's say I am I'm working on the topology optimization for predefined parts. This is a task, and if I open it, double click on it, then this is the title, description, the parent project. You can set the priority as well. Maturity is there, percent complete. So let's say currently it is saying that 35% is completed, and Greg and I together work on this today, and it comes to 50, then you can drag it to set that it's a 50% done.
More, a little
Here
like
you
75.
can, yeah. Yeah, deadline is very close. 19 May is a deadline for that. So you can set the actual start and planned end for that. Estimation dates are there, and let's say if you have some attachments for that, any image or Excel file or any CAD for that matter, you can upload, attach that attachment over here. And here you can see the responsible file folder. So common space is a collaborative space where you can see all the attachments. So this is all about your task, and this is the member. So assignees are Greg and I, and owner for this particular project and task is myself. And you can add comment to this one particularly. If I want to say that, Greg, I have done this much of work, please take care of the next item, then I can tag you over here, and the notification will pop up in your window, Greg, so that you will get notification that yes, I have to do this next task. Saga has done this much, the remaining part is this, and we have to complete it by that particular target date. So by this way you can collaborate, you can communicate with your teammates through the collaborative task. So this is the most important phase, planning and task assigning. After that, if you have a result and simulation results, and if you want to see it, you want to review it. So let's say this particular object is casing of that battery module of a e-bike, and we have done plastic simulation over here, and it is a warp simulation. So if I play this, you will see the animation, and one particular strip is coming out from that 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 it's deforming way higher. So a question might be there that, hey Saga, this looks very unrealistic. Is it the real thing? The strip is coming out far away from that particular that original position. So it's just because it's having deformation scale. So while exporting, yes, go ahead. Great.
Yeah, so this is to Sean's question he had earlier was about results. So thanks for sending that question through. Here we can obviously see the results.
Yes, we can always see the results with a different, I mean, we have a set of capabilities where you can review result, you can comment on it and go back to design in SolidWorks and make some changes and come back to the platform and rerun it.
Yeah, yeah,
So this is a warp simulation having 10.8 deformation scale. That's why it looks like unrealistic. But if I set the deformation as a 1, then probably it will be too small to identify or to notice what deformation is there in a warp simulation. So here you can have a different set of content. So for these particular simulation results, I have a mesh quality and displacement total in a warp simulation. Then for pack and cool simulation, there will be pressure, temperature variations, and for field simulation, these many results. Output request were set while submitting simulation. So while submitting simulation on cloud, you just need to make sure that you are toggle on to the generate three experience content. If you generate that, it will be lightweighted content. You can easily see in a 3D play or in a simulation result review. So this way you can select whatever you want to see, the simulation results basically. And after that, I will go to the performance trade-off, where you can, I mean, these two are everything, whatever I'm showing right now is a part of 3D Experience Work simulation portfolio. So if you have alternative designs and you want to uh, perform a trade-off between those designs, then this is a tool for you. So we have different, so here we have e-bike motor performance trade-off with the three alternative designs and requirements. These are all uh, requirements data set. You can easily filter it out over here. So let's say I want to target only these many uh, requirements, where total motor mass is the first priority, and I have set it as a minimize total motor mass.
So
So
are these results from like a DOE or something, like a design of experiments, and then it's just showing you the variations of
yes,
those?
yes, yes. So we perform DOE on e-bike motor performance, and it's like hundreds of results were there, out of which this is a baseline motor design. Then we consider intermediate as a design iteration of a 25th, and this is the best one, which is having rank 1 score 100. So if you target these requirements and prioritize it, you can also, let me show you one out of which, let's say total motor mass. So this is a way where you can set your
Okay,
priority out of 5. Then objective. So you want to maximize it, you can, you have, if you have a specific target, then you can also add that. Even if you play in range, so just like this top maximum, that is having range from 35 to
hmm
100. So if you want to have a threshold, then you can have it, and just set it as is, and software or the platform will perform at the back end and give you
so
results. So
I basically, what do? I just like set up my simulation and give it like parametric boundaries or whatever, and then it stores the results that I tell it to store for each iteration, and then I it,
yes,
I can just, I don't have to look at those individually. I can use this tool to kind of help pinpoint
correct, correct.
which ones are the best performing.
And
Wow.
even if you can go for several iterations, so need not necessary to limit that, yes, I'm doing it manually, just go for 10 iterations. Not like that, you can go way, I mean, for hundred and thousands iterations,
Okay.
but depending on a time you are having for your project. So for this particular motor, we go for 100 iterations, and out of which this particular, the middle one, is the best or the optimum one.
Cool.
I would say good one. So by using performance trade-off, you can directly choose which is best suit for your requirements. So this is about performance trade-off and collaborating on a dashboard. If anyone is having questions, please shoot. I am ready to answer. I think we are on time.
Yeah. This is great. Thanks. I mean, I know a bit about doing the structural simulation and stuff, but I think that's what's even going to be fun for me following this series along is I'm no CFD expert. You know, in the dashboard, you know, don't tell anybody, but I'm really bad at the stuff in the dashboard. And so this is great. I'm really enjoying seeing this myself because, and I know some stuff's in there, but you know, I haven't spent a lot of time in there myself. And so this is, I mean, this is awesome. Just that way to collaborate with other people
Yes, yes,
is
yes,
really
yes.
nice. I mean, nobody likes email, right? I mean, I think I even saw that in the comments. I mean,
Yeah.
oh man, yeah, email's tough. So yeah, exactly. A comment.
Yeah.
Maureen says she doesn't like email in the middle of the day. I don't like email any time of day, like because email, chats, message. You know, sometimes it gets confusing,
Yes,
and
yes, yes. You get lost in email
yeah,
conversations.
yeah. Um, so that's really good. Let's see. So thanks for showing that. Let's scroll through and see if we have any other questions that we haven't answered along the way. Um, I think there was a question earlier that Ryan answered about. Yes, about boundary conditions. That's the one that I was going to get to. Yeah, setting up boundary conditions in a simulation. The old saying goes garbage in, garbage out, right? So you do have to put in appropriate boundary conditions, and depending on the simulation you're trying to run, your boundary conditions could be different. In the scenario that
Yeah.
I was doing, I was just putting some boundary conditions on there. Realistically, I probably would change those boundary conditions and put them slightly in a different location, maybe where they're going to be strapped a little bit better to the head or something like that. But with some training, you can pretty easily understand where those boundary conditions need to be. But at the same time, those boundary conditions I put on there were valid for just a standard kind of displacement on that helmet as well. So again, it's all about what your intent is and what your goal is for those particular boundary conditions. So yes, it does matter. Yeah. Let's see. Any other questions we have through here? Scrolling through. Yeah, riding without a helmet, no good. That is the pro tip of the day. Yes.
Yes.
Yeah, for sure. There was another question in here. I'm trying to remember who asked it about guidance of what types of meshes and elements to use.
Yeah.
I wouldn't say in particular the software guides you on what meshes to use. We do have some informationals about what types of meshes to use for certain types of simulations, but we do have tools in the platform that you can use to help you figure out if your mesh is at a refined enough density, let's say. So we've got some tools in there that will help you understand how to decide if you need to increase the mesh refinement that you have in there. And then there's some other things that we can use, just like through a guidance checklist to determine if you think your mesh quality. Also that's it. That we have a mesh quality checker as well to the shape of the elements in there.
Yes, and
you had a comment?
Yeah, and I think we are going to cover these aspects of meshing and how simulation model should be built in our next coming up session.
Yeah.
And I would be happy to announce that over here it will be on 14th of June, and the target topic is simulation model build. So if you are working on any simulation, then what things needs to be considered, how you should mesh, how rule mesh is there, how you can set the boundary conditions, what other things are there, you will get to know on that particular session. And Greg will be again presenting that session.
So sorry, everybody, you're gonna have to listen to me again, yammer on. But yeah, so again, this was just an overview of a lot of the different tools or process of what you can do on the platform. And now through the next series, we're going to really start to dive into the details. And I'm even going to do a session of preparing the geometry for simulation. Like, how do I even prepare the geometry? How do I remove some of these features in there and stuff that I do or don't want to?
Yes. So thanks, Greg, for joining us today, and thank you everyone for being a interesting audience to us, interactive audience to us. So thank you for your time.
Yep.
So just the housekeeping thing. Again, if you haven't subscribed the channel, please go subscribe, like, and share the videos and channel. Till then, we will meet again on 14th of June. Till then, bye everyone. Good night, good afternoon, good evening.
Right. remember, like and subscribe and come back. So thanks, everybody.
Yeah. Thank you.